Now, here we have question number 21 from October, November 2013, variant 2-1, paper 2, variant 1. You'll notice I have this kind of watermark in the background because, as I mentioned in one of my videos, some guy has been copying my video. In fact, he copied one video so far and put it on a different channel. He was spamming this channel, telling you guys to go to his channel, and his name was Your IGCSE Maths Tutor. And he's taken one of my videos and put it up there, and it's like I went to see what kind of explanation he gives, and I was just shocked to hear my own voice, my own video that I've uploaded here. So if you see any background like this on any other channel, you know that that video has been stolen from my channel. Okay, the videos on my channel, the ones I've done already, of course, don't have these. But any future ones that you see, okay, in any other channel, right, with my voice, okay, then of course it's been stolen from my channel. Now, here we have ABCD. It's a kite. ABCD. Kite is a special type of quadrilateral. The diagonals AC and BD, they intersect at X. AC, one of the diagonals, is 12 centimeters, and BD, the other diagonal, is 20 centimeters. Okay, so that's 20 centimeters. I'll just write that there. And here, AC is 12 centimeters. I'll write it on this side here. Now, in a kite is a special type of quadrilateral. There's certain properties that it has. One of them is that the adjacent sides are equal to each other. So BC and BA, CD and AD, they're equal to each other. The other thing is the longer diagonal bisects the shorter diagonal. So this diagonal from BD bisects, cuts in half the diagonal AC. So this length here, I'll put 3 lines to distinguish from the others, are equal. So X to C and X to A are the same. So if 12 centimeters is the length from C to A, okay, that's at 12 centimeters, then 6 centimeters must be from C to X. Okay, now this question tells us to calculate the angle ABC, which is this angle over here. I'm going to call that angle X. Alright, now one of the things we know about kites is that the diagonals intersect at right angles. So you have right angles here. Okay, these are 4 right angles here. Okay, and we can see I'm able to spot a way to find this angle. So if I take the whole of the angle, okay, the whole of this angle here, then this part of the angle, I'm going to call it x over 2. That's just a good way to remind us not to forget that we're finding half the angle we need. Because a lot of people, they find this angle and think they're finished, but the angle we need is actually the whole thing, which is twice the angle. So a good way to remind yourself is to call it half of the angle you need, x over 2. All right, so I'm going to draw this triangle, which is X, C, B, outside of the shape. Not a really good triangle, but you know what I'm doing. That's x over 2. I'm going to call it x over 2 to remind myself to have to multiply by 2 to get my answer, which is the whole angle ABC. Now I know this side is 6. I don't have any other information apparently, explicitly. So I think you know, a lot of students will get stuck at this stage. Okay, I know this is a right angle. I need one other length, and it looks apparently that they haven't given us another length. So some people say, okay, what can we do now? We're stuck. They gave us another piece of information. They didn't give us another piece of information just for decoration, just because it looks nice having a ratio there. That's going to help us to solve a problem. Okay, so they gave this information because there's a reason for it to help us solve the question. Okay, so it tells us that the ratio of dx to xb is 3 to 2. Dx to xb is, there's 3 parts and that's 2 parts. So I'm not going to write, it's not the length, it's a ratio. Okay, so that length db, you can say, is made up of 5 parts, and 2 parts out of those 5 are the length from x to b. This is x here, x to b. So this is 2 parts out of 5 parts of the whole of this line. So it's 2/5 of the whole of this line. So x to b will be 2/5 of the length from b to d. And we know that b to d is 20 centimeters. So it's going to be 2/5 times 20, or 5 goes into 20 4 times. 2 4s are 8. So I know now that x to b is 8 centimeters. Now I can work out this angle, and then I can double it. So I can work out the angle. I know that the tangent of the angle x over 2 is equal to opposite over adjacent 6 over 8. I skipped a step there. Most of you should know now, if you have a right angle triangle, we'll apply Sohcahtoa. Okay, we'll apply Sohcahtoa to this triangle. Basically, this helps us to remember the ratios of sine, cosine, and tangent. The sine ratio is opposite over hypotenuse. Well, I don't have the hypotenuse. The cosine ratio is adjacent over hypotenuse. Well, I don't have the hypotenuse. The tangent ratio is opposite over adjacent. So I know that the tangent of this angle is the same value as 6 over 8. So now I can just, in my calculator, type in inverse tan of 6 over 8. Okay, and we'll see what happens there. There's my calculator. There it goes. Okay, I've already done it there actually. I'll just do it again so you can see. Shift inverse tan, that means shift tan gives you the inverse of tan. Bracket 6 over 8. I could put 3 over 4 if I wanted to. Okay, and then close bracket. Now, before you do anything, just make sure it says D there. It's a degree mode, that's fine. If it says R or G mode, then you must change it to degree mode. You can change it by going shift and mode. It depends on your calculator, actually. This one, you press shift mode, then 3. It really depends on the calculator that you have. Okay, so I'll just put 3, just so we know it's in degree mode. Okay, now we can press equals. Now that gives us 36.869 ... So x over 2 equals 36.869. It continues on and on. I'll put ... because I'm not rounding it here. And I know that x is going to be twice that. Okay, because we found just half the angle. So but by rewriting it as x over 2, it helps us to not forget. Many students, they get to this stage and they forget that they were finding half the angle and they think they finished. Okay, so x is 2 times the angle. So you take the angle that we've got in the calculator and you just multiply it by 2, and it gives you 73.7397, 73.7397. Continues on. Now it says calculate angle ABC. Now angles should always be given to the nearest degree. So sorry, to the 1 decimal place. Angles should always be given to 1 decimal place unless otherwise specified, as it says in the front of your paper. So it's 73.7 degrees. So that's angle ABC, 73.7 degrees. Okay, and now the next part of the question, where did I put it? I didn't put it here. Let me take it quickly. Next part of the question is actually quite easy. I wasn't actually asked to do it, but I will give you this question, seeing as it's just for completeness sake. Now for this question, I'll just copy this and put it on my, oops, it's busted. Sorry about that. Let's just close that. Oh, disaster here. 1 second. I shouldn't do that when I'm in the mode of thing. Okay, that's sorted out now, I think. Let me go back here. It's telling us to calculate the area of the kite. Okay, so the part B says calculate the area of the kite. Now the area of a kite, it's very easy. It's a half times the product of the diagonals. Half times A times B. Very simple. So it's a half times 20 times 12. Simple as that. Half times 20 times 12. Okay, a half times 20 is 10, and 10 times 12 is 120. So that's the answer for part B, 120 centimeters squared. So that's B done for us as well as A. And I will sign off from this video now. So remember, you see my videos, okay, without this in the background from now on, okay, in some other channel, that's not me, okay? That's not me. Thank you.